Hello everyone, my name is Jen. I came from SK Telecom. I'm sort of like working as a manager at SK Telecom. So for this talk, we are internally using ONOS to implement our own Cloud Beam. So today I would like to give a introductory talk about our solution. So we are trying. So now we are in a verification phase, and once we've done a set of the verification phase passed, then we will be eventually put our solution into our production 5G. So now we already launched the 5G services, but this is in the first phase. So there are going to be a series of phases that we have to go on, and hopefully we can put our solution into our 5G phase 2, so that eventually you're gonna sort of like using the ONOS in our data center. So SONA. So today's talk is about SONA. So this is a carrier-grade data center network management solution, and internally we are using ONOS to implement the whole stacks. So this is the agenda. First of all, I would like to give a brief talk about the introduction, and then I guess some people may not quite aware of SONA, so I would like to give a summary talk about this some main features that the SONA provide, and also recently we also added a set of features based on the requirements from the operator side, and then I would like to give some introduction about the QA part and as well as security, because in order to put our solution into the production, verification is very important, and we internally run our own CI/CD pipelines. And once this pipeline has been passed, then we're gonna push the code into the ONOS side and so on. So I would like to go through the phases, and then I would like to give a talk about the collaboration, because this is open source project, but we are also put our solution into some commercial product, like a commercialized version of OpenStack and so on. So I would like to give a brief talk about that one, and also I'd like to show the roadmap that we are planning for the next year. So motivation, so why we are doing this SONA. So actually from 4G, we already virtualized most of the network functions, and now in the 5G, we will be eventually put all the VNF into the CNF. That's our big vision. So in these circumstances, managing this virtual network has become very important, and still now Kubernetes has become very popular in the industry, and a lot of telcos want to adopt that, but still a lot of telcos still using OpenStack to realize their own a virtual infrastructure management. So our target as a first phase is managing this OpenStack network, right? But there are already OpenStack networks management solution ready there. So if we are using the default Neutron implementation, we faced a lot of problems, and some of the so we found that the default Neutron implementation doesn't really fit the telco requirements in terms of performance as well as flexibility and so on. So we decided to replace the default Neutron implementation using the SDN controller. So we implement the SONA on top of ONOS to replace the Neutron implementation, so that to meet the very stringent requirements from telco side. And also the second motivation is most of the vendors, they bring their own overlay network management solutions, and if we are adopting all of them, then somehow we need to integrate all the overlay network solutions, and that becomes another burden. And also it introduce under vendor lock-in. So we would like to implement our own overlay network management solution, so that the underlay gonna be adopted from the multi vendor, but the overlay side we are still just using one our own solution to manage the whole VM networks and so on. And we closely looked into the ONOS and core community side, and we found that there's one very similar project called Core VTN. This is also another implementation of overlay network management solution, but the problem is that the Core VTN is very tightly coupled with the core use cases. So it's only realized this core use case, and we cannot use core VTN for general purpose. So we decided to implement our own VTN, and we call that the SONA. And if you take a look at the default OpenStack network, if we deploy all the stuff, then it looks like this. So it has one control, maybe one or maybe three control node and a set of like compute nodes and a set of like a network node. But in most of the cases, we only have one network node. So the network node becomes the bottleneck. And if you take a look at the picture, there are so many agents installed by default if you install OpenStack. And managing those agents is really pain in the ass. Actually, it's really generate a lot of like problems. And one of the agents like failed for some reason, then we have to detect that and need to do some like a failover, like a mechanism and so on. So that is another burden. So what we decided is we tried to get rid of all these agents. So this agent is just for managing the network. And instead, we just use one SONA to replace all the features that this agent provide. And SONA runs on top of ONOS, so it's sort of like supporting the HA and so on. So that's the beauty of SDN controller. And also, in the previous slide, if you can see, there's one network node, but if we, after SONA also supports multiple gateway, so we can replicate all the gateways into the pools, and so that we can sort of like supporting the scalability for the north-south like traffics and so on. And then another thing is our SONA also support a set of like a data plane acceleration, like the technology like DPDK and the SRILV and the PCIPT and so on. So, but if you're using default the neutral, you will have to configure that manually, and that also brings a lot of like problems. So SONA stands for the Simplified Overlay Networking Architecture, and we are using ONOS to build up whole like stacks. And now our solution support three types of virtual network type. One is VXLAN, VLAN, and the FLAN. And we can maybe extend, it's sort of like supporting more network types maybe later on, but now our operator only make this type of requirements, so three types are supported. And also we support a set of like a data plane acceleration models. One is OVS DPDK, SRLV, PCIPT, and smart NICs. So recently we found that this smart NIC can offload a lot of like OVS, like a traffic management stuff into the physical NIC card side. So in that case, we do not need to change any code and control plane, but still can leverage a lot of like, the OVS flexibility, as well as we can also, so that also give us a lot of like performance side upgrade. And so we are maybe later on can move to that direction as well. But for now, we're sort of like supporting four types, TPM model. And also OpenStack has a multiple like versions, and now SONA supports the OpenStack from Mitaka to Rocky, and we are now testing our solution against the Stain, which is the latest version of OpenStack. And so if you look at the architecture, the OpenStack side, and SONA is resides on top of ONOS, and we have a set of like ONOS application to realize the thing. And the one important component is OpenStack node and OpenStack networking. So through the OpenStack networking, we are installing the flow rules into the OVS, which were installed in like a compute node and also in a gateway. And using this type of architecture, we realize our solution. Okay, so the main feature. So so definitely we are sort of supporting like a L2 switching. This is very obvious. It should be supported. And the next feature is L3 routing. So in that case, we have to go through the gateway, and the two VM are reside in a different like a subnet can workable. And also we can ping to the out of cloud, like Google's and some other site from the VM. And the security gateway, this is the security group. This is a little bit tricky because in order to realize the security group, we somehow need to realize the stateful firewall like features in using the ONOS. But as you know, OVS is a stateless like open flow switch. So in order to realize the stateful firewall, we used the contract module, which was supported in a kernel space. And the IP tables also use that. So NetFilter also use the same module to realize the stateful firewall. So we also use that type of mechanism to support the security group. So for a certain like a VM like a connection, we can use this mechanism to ban or maybe allow a certain like traffic can go through the path or not. That's the thing. And if you go with the Kubernetes, there's an ingress like a stateful load balancer, and then, that can also be realized by using the similar mechanisms. And this is the scalable gateway, so we can replicate the gateway, and depending on how much traffic flows between, like a north-south traffic between the VM to outside, and so on. So this is the new features that we were recently added. So the one of the features is the telemetry. So it's sort of like collecting the virtual network real-time like statistics, and we are sort of supporting two collecting schemes. One is a port-based the traffic statistics, and another one is a 5-tuple-based VM to VM flow statistics. So fortunately, the ONOS already support port-based traffic statistics by default. So we just leverage that like a feature to realize this one. And for flow statistics, we implement our own like schemes to collecting the statistics. And the beauty of this the feature is there's no additional like overhead generated if you are using this one, because it just collects state using the OpenFlow protocol. And also we provide some integration of this feature into various like northbound APIs. So for example, the REST Kafka and the InfluxDB and the Prometheus. And so InfluxDB and the Prometheus is well known, and also Kafka is well known. And we provide the open source version of InfluxDB and the Prometheus support. And for Kafka, we open source some part, but our solution, our own network analyzing like system is a proprietary sort of. So that integration part is not being supported by default. But if you're interested about that part, we also can consider open source that part as well. So, but the main feature of telemetry is open source. So you can just go to the ONOS repository, you can take a look at the code. So this is the GUI. So we push our metric into the InfluxDB or Prometheus export. Then we are using the Grafana to visualize the whole things by pulling the metrics from the database, like InfluxDB and Prometheus database and so on. So this is GUI, and this is can dynamically generate all the stats and the things, and you can see what's going on in the virtual network side. And this is the video. So this is our sort of like a proprietary network analyzing like system. We also push our metrics into the system through the Kafka. So I would like to show some. This is a very short demo, like demo video. So this is the South Korea territory. So there are a set of like a CO we have and created by default. And this is our data center, for example, and a lot of racks existed. And we collect the host like information through the SNMP agent, which has been installed in each host. And then a similar thing happened in the physical switch side. Unfortunately, we are not using the white box like a switch to realize whole like things, but internally in each compute node we installed OVS, so we can collect these OpenFlow like metrics from that side and so on. So this part is not quite related to ONOS, but if we go into each rack and click on the computer, then like a server, then it's gonna show you the virtual like a network topology, and in that side we can like push a metrics, and the metric gonna be shown and so on. So this is a physical side, and for logical side, let me check. So yeah, it also sort of like providing. So this is a local like a network topology, and the metrics shown here is sort of collected through the ONOS. So our sort of solution is sort of like integrated with our own like network analyzing system already. And the virtual tap. So this is sort of like very important like features to troubleshoot when a certain VM to VM network has some like a problem. So in that case, we just mirroring all the that traffic to another VDPI VNF to analyze what is happening between two VMs. And we provide sort of two traffic monitoring schemes. One is port-based, which is very specific to the OVS. Another one is a flow-based. And in order to realize this flow-based, we're using the multi-group table feature provided by the OVS. And I think this feature is provided in OVS 2.6. So if you're using the version which is lower than that version, this type of feature cannot be provided by default. And for the performance, we also can leverage several DPA technology to further enhance the tapping performance as well. And also this part has been open source ready, so you can go into ONOS repository, can see the code and can run and to test. So this is GUI. So there are two interfaces provided. One is a GUI. So once this application has been activated, you can just put the source IP, destination IP, and port, and types, and so on. Then the traffic between two VMs will be automatically cloned and sent to the destined the VDPI VNF. Then on that side you can debug, and maybe you can run some Wireshark or some other debugging tools to see what's happening on a certain link. Okay, so if we want to put our solution into production, the most important thing is verification. We have to pass all the verifications, and internally we are running our own OpenStack integration test, because our solution is sort of it's OpenStack a little bit specific, like a case. So somehow with our solution, all the OpenStack like use cases supposed to be passed. Otherwise, there might be some bugs or maybe problem on our implementation. So we are running. So Tempest is a well-known integration test tool in OpenStack side, and we are leveraging this Tempest to construct our own like CI/CD pipelines. So Tempest consists of two test case. One is a API test case. Another one is a scenario test case. So API test case is very straightforward. This is just we execute a certain API calls, and we just check whether that API gonna give us the right result, and so on. And that API is through the REST. And the API part is quite simple, but the scenario, there are so many scenario tests being added into the OpenStack, so we have to pass all the scenarios in each a code commit. And the rally is intended to provide the testing framework. So sort of because if you are running Rally, that also exploits the Tempest to run a set of verification test. Also with Rally, we can run some benchmark test and performance test as well. So eventually we are now using Rally, but if you just want to test the functionality of SONA, you just need to run Tempest. That also give you the result well. So the neutron test case, because OpenStack is quite big and we cannot run all tests which is not relevant to the network side. So we try to scope down that a little bit, and this is the test case which is related to the networking side. So the API test case there are maybe around 340 API test cases, and then our SONA can test against this API and can pass all the API calls. And then the scenario test, 33 or maybe 34 scenario test cases. And so these test cases sort of I just summarized the whole test cases here, and it's rich, including very basic tests. So with this scenario test, we just instantiate two VMs and to test whether the two VMs are connectable, through ping and so on. So which is very similar to MINET, but this is a bit more realistic compared to the MINET. MINET is sort of we are using some virtual process to mimic one host, but in this case it's real VM, so it's a bit more realistic. And we test a lot of scenarios here, and now SONA passed all the scenarios in normal development sites. So versioning. So this is a bit tricky because ONOS the bump up too frequently, and now it's just so in each 4 maybe 5 months you're gonna release a new version, and it's very difficult to cherry pick all the changes into the old version. That's a little bit painful. So what we decided is so up to ONOS 1.15 is sort of compatible with 1.14 or maybe 16. So the 13. So what we decided is we always put our code into 1.15 as well as the master, which is 2.0, and then we clone all the SONA's code from 1.15 back to the 1.13 or maybe 14 for testing. And then if test like a pass, then we packaging all the the solutions in different branches. So here we are now maintaining 4 branches. One is stable branch, which is based on ONOS 1.13, plus with the latest version of SONA, and the master branch is ONOS 1.14, dev is 1.15, incubate is 2.0. So we can say literally it support all sort of recent ONOS branches. So now we are running our CI/CD testing against all branches, and they all passes. So this is the current status. And this is a CI/CD part. So for CI part, there are several procedures we are running. One is we try to test whether our solution is built against the ONOS platform without any error. And then we are running unit test, and also we are running the full static code analysis. And then we are running the integration tests from the OpenStack side, like API invocation test as well as OpenStack scenario test and so on. And also we are testing ONOS SONA failure and the recovery test as well. So this part has been done by ourselves. And the continuous delivery, then the output gonna be the Docker container image. Then we deliver that into our a staging environment to test whether all features been work properly. So this is the CI/CD pipeline what we have, and it's running in each commit or maybe in nightly manner. And to summarize that part, once we have a new patch from the OpenStack, from ONOS side, we try to merge it into the ONOS stable a source, which can be 1.13 or 14 or 15 or maybe 2.0. And then based on that source, we try to build the whole thing. And then it will be the output of this build gonna be the newly built SONA apps, which is a set of apps what I have introduced. And then we try to pull the Docker images from Docker registry. So the Docker, so this Docker image is comprised of ONOS base image plus the nightly built SONA. And then we try to replace the newly built SONA apps with the nightly built SONA apps. Then we pull the Rally integration test tool, and then we try to verify whether our solution works properly. And if it passes all the verification, then we try to push our result back to the Docker registry, so that in a staging environment, it always can refer to the SONA Docker images, which has been pushed into Docker registry and so on. And this is a little bit complex diagram. So we all integration test tool code as well as some utility what we have implemented has been open source already. So initially we were using the ONOS SONA bug tool to build the SONA, but I just recently found that the bug script has been wiped out from the 1.15. So we have to implement the Bazel tool as well. So it's a lot of work, but anyway, now we are sort of supporting Bazel build as well. So this is the whole pipeline what we have. So we pushed all the code into GitHub. So if you feel interested about this part, you can download and to see. And some Docker a script file has also been open source, and the registry is also available here. And the CI part is a little bit complex. So this is just so you can briefly see the whole flows. And then the CD part. So once we've done all the tests, then we're gonna eventually push this into the Docker cloud and send the notifications through the Slack. So also we are also checking the security part. So we are internally using the Black Dog Hub to check the security part. But fortunately, ONOS, it doesn't show a lot of like defects from this like a dashboard. So so security risk, there's only one medium level like a security risk, which is related to jQuery. I found that ONOS sort of using very old version of jQuery, which has been wrapped with the Swagger. So I think it'd be good to bump up the Swagger because Swagger version is a little bit out of date. So that probably should be done maybe later on. And the licensing risk is quite low as well. And the operational risk is kind of viable. And the operational risk is sort of related with the JSON patch stuff, so which is related to web. So I don't think this is really critical at this moment. And the ARP resolution. So in the production, we're assuming that the control plane can be failed in all cases for some reason. So what we are trying to do is we are sort of supporting two modes. One is a proxy mode, another one is a broadcast mode. So even if the control plane is entirely like failed, our SONA solution is still supposed to be runnable. So in order to realize that, initially the SONA sort of implemented the proxy, like ARP proxy like stuff. But now we are also trying to support the broadcast mode as well. So the broadcast mode is, so proxy mode is like this. So if you want to ping from one host to another, typically we just send the ARP request, and then this will be like wrapped into the packet message and sent to the controller, and the controller will resolve and it's gonna be sent out the ARP reply back to the host 2. Then the whole like ARP resolution works. But in some cases, the ONOS is failed for some reason, or yeah, in that case, we need to find another backup solution. So the backup solution will be you send the ARP request, and that's gonna be broadcasted to all like the hosts. And if the host located into the remote, then we encapsulate the ARP into the VXLAN or maybe VLAN, depending on what type of network you are using. Then it's gonna send back the ARP reply, and in this case we also encapsulate that part and send back to the host. So with this mechanism, even if the ONOS is failed, doesn't work entirely, like the whole control plane is failed, we found that the data plane still works properly. So in the production, in real production, I think we're gonna deploy the SONA in this mode, with this mode. So finally is the flow recovery. So flow recovery is a little bit tricky because once the flow is failed, so once the control plane is failed and we restart the control plane, then all the flow rules will be wiped out because there are going to be no flows in the control plane. Then it also wipe out all the flows in data plane as well. So we internally allowed it the extraneous rules like option as a true, but maybe in the long term, I think almost it'd be good to see that ONOS can support the flow recovery from the data plane to control plane side. There's one thing. And now if we want to use SONA, we can say the SONA is available in Helion, which is a HPE like a commercial version of OpenStack. So we integrate our SONA with the commercial like HP OpenStack, and it works well, and it all passes their verification like internal the test. So if you want to use that, you can contact the HP to use our solution. So this is a roadmap. So in the next year, we would like to provide the cloud native support. So which is just for Kubernetes. And the second thing is we would like to use the P4 enabled SmartNIC to match the layer 7 like packet as well, so that we can provide a bit more enhanced feature. And we need some help from the community. One is a SFC and XaaS, which is VPN as a service, load balance as a service, firewall as a service, and IPv6 support, and more verification feedbacks from the community. So if you're interested about those features, you can feel free to just contact us and contribute to the SONA project. So this is the end of my talk. Thanks. So if you have any question, okay.
Somewhere in the slides you mentioned that the SONA solution support VXLAN, VLAN, and flat.
Yes.
But later in some slide you mentioned GRE also somewhere.
So GRE, that part is different. So that is for VTAP, like a
Yes,
like a
for
mirroring
VTAP,
part, there are several solutions, but we are just tapping. So for only for that part, we are using GRE tunnel or VXLAN tunnel to mirror the traffic to the remote.
So what is the need of GRE here? Why do you want? Why do you need to GRE to support here?
GRE, so it's an option. So you can use just VXLAN, or this is a sort of option because our business partners, they implement it this way. So and maybe if you're interested, we can maybe use some other tunneling protocol to mirror the traffic as well.
Another thing that I wanted to ask, how do you support these DPA technologies in OVS? So
okay, so DPA technology. So there, if you take a look at the OpenStack, like a networking side, there are a set of like plugins for supporting this DPA. And in order to use a certain DPA technology, you have to install or maybe activate that plugins, and that requires a lot of like configurations and thing. But we actually sort of integrate that all like stuff into our networking ONOS like plugins. That is in OpenStack side. So if you want to use a certain DPA technology, just activate SONA and using SONA. That's it. There no need to install some other like plugins in OpenStack side. And like port creation and those stuff is already been supported inside SONA. So
that is stuff inside OpenStack is also
we are maintaining two
sourced.
things. Yeah, we are pushing code into ONOS as well, and also at the same time we push code into OpenStack side because this is supposed to be integrated, right? So our team are doing two things. So one is OpenStack support and ONOS support.
Thank you.
Okay, thanks.
You said you removed some plugins from OpenStack, right, and added your own gateway servers.
Gateway servers.
Yeah.
Oh, so what do you mean by gateway servers? Do you mean the network node in OpenStack side?
Yeah.
Okay, so here, so I can say so this one, right? So if you're using our solution, you do not need to install the network node because all the agent role has been replaced by SONA. So like DHCP and ARP stuff, or can also all be done inside like ONOS. So no need to install extra network node. And if you have very heavy traffic, like heavy north-south traffic, you also can scale this gateway pools. And this gateway pools is nothing but OVS. Like a computer installed in a certain OVS. And if you're using the smart NICs, like provided from the maybe Caviums or Mellanox, you can install multiple like smart NICs in one computer node and you scale in and out all the like north-south traffics.
And another question I had: do you plan to use SONA on top of SEBA, or does it make any sense?
Using SONA, as far as I know, SEBA doesn't use the VM network. They are all containerized.
Yeah.
So one thing is, so now we have planned to support container network in the next year. So once that part has been done, then you can use SONA to control the container network as well. Yeah, but for current like status, it's not possible.
Okay. Thanks.
Okay.
Just
maybe one more.
Just one question.
Yeah.
So Trellis is for underlying network.
Yeah, this is for overlay.
And this is for overlay. So can we both use both together?
Yeah, why not? Yeah, you can. But we somehow need to do some integration between overlay and network. So overlay or maybe underlay, because this is two independent projects. But yeah, it's possible. Yeah.
Okay, thank you.
Thank you.